In this presentation, we are going to talk about density. Density is the mass per unit volume, but also we can define density as the ratio between mass to volume. The symbol we use to identify the density is the Greek letter ρ. So we can define density, or the equation of the density is the mass density equals to mass over volume. What is mass? Mass is the amount of matter that makes up an object. Then mass is related to the matter. Also, we can define the mass in terms of how difficult it is to move an object. Then, for example, if you had object with larger mass, it's more difficult to start moving, or it's more difficult to stop that object if the object is moving. Then the resistance of this object to change in motion is called the inertia. Then we can define the mass in terms of the matter or the inertia. The units for mass can be kilograms in the international system, or in the Gaussian system or CGS system, the unit is gram. Then always, if you have this unit, you know the number or the property you had is related to the mass. Volume is the space that an object occupies. Then we know we can calculate the volume of the object. If we had a regular object, we can use an equation. For example, if we want to calculate the volume for a cube, we know we can use L is the size. If we had the sphere, like is in this case, the volume of this sphere, then we can use this, where R is the radius of the sphere. Then we can use some equation if we had the regular objects. But if we had irregular objects, then we had to use different methods. One method we can use the water displacement method to calculate the volume. Then in this, if we had this bowling ball, then the mass, yes, the mass is how much matter makes up this ball, and the volume, if we know the radius, then we can calculate the volume using this equation. Yes, because this is a regular shape. We know the volume is a derivative unit. This is why the units of volume can be cubic meters or can be cubic centimeters. Yes, this is those possible units for volume. Now we are going to talk about the density of water, and it is important to discuss the density of water because it's a reference density. Means we can compare the density of any material with the density of the water. Let's see why we can compare easily the density of water with the density of any material. Then let's think we had a cube. The size of this cube is 10 centimeters, 10 centimeters, 10 centimeters. Then the volume of this cube is 1000 cubic centimeters. If we fill out this cube with water, and the volume of the water will be 1000 cubic centimeters. Then one more thing I want you remember, this is important, is 1 cubic centimeters equals to 1 milliliters. And these two units are the same. And this is we had right here. Yes. Then 1 cubic centimeters equals to 1 milliliter. This is why if we had 1000 cubic centimeters, yes, if the volume of the water is 1000 cubic centimeters, then it's the same as we say the volume of water is 1,000 milliliters. If we were able to measure the mass of this mass, we will find that the mass is 1,000 grams. Then let's calculate, using this information, let's calculate the density of the water. Then the density of the water will be 1,000 grams, because density is mass over volume, will be 1,000 grams divided by the volume. The volume is 1,000 cubic centimeters. And 1,000 divided by 1,000 is 1. Then we can calculate the density of water, which is 1 gram per cubic centimeters. And we know these two units are the same, yes? It's the same thing. Then we can also express the density of the water as 1 gram. The density of the water is 1 gram per milliliter. And now we know, this is why it's easier to compare any density with the density of the water, because the density of the water is 1. Yes, it's 1. This is the reference density. One more thing is also, if we had 1 liter of water, and if we were able to measure the mass of this 1 liter of water, we will find the mass is 1 kilogram. And now with this information, we can calculate the density of the water is mass, which is 1 kilogram, divided by volume, which is 1 liter, and 1 divided by 1 is 1, then we will have the density of the water is 1 kilogram per liter. And there are 3 different units which we can express the density of the water. Yes, we can say the density of the water is 1 gram per cubic centimeters, the density of the water is 1 gram per milliliter, or 1 kilogram per liter. Yes. This is what we had in this, we summarized in this part. Yes. This is what we had summarized. Then is this here is important to remember. Yes. In case of water, just this happened in case of water. 1 cubic centimeters, the mass of 1 cubic centimeters of water equals to 1 gram. And remember, this is true for in all the cases, 1 cubic centimeters equal to 1 milliliter. And also, this is true only for water. The mass of 1 liter of water is 1 kilogram. And now we can write the density of water. Yes, we can write the density of water in terms of different units. And we had now the density of water can be 1 gram per cubic centimeters, can be 1 gram per milliliter, 1 kilogram per liter. Another important way we can express the density of water, the density is 1,000 kilograms per cubic meter. And this is all are different units we can use to express the density of water. Then you can see 1 gram per cubic centimeters equal to 1,000 kilograms per cubic meters. These are in Gaussian units or CGS units. This is an SI system. Yes. And if we need to convert from this unit from gram to cubic centimeters to kilogram per cubic meters, just what we need to do is just multiply by 1,000. Yes. But what we will do in the next slide is we will prove that the 1 gram per cubic centimeters equals to 1,000 gram per cubic meters. And we will prove this equals to this one. And let's see that. And we want to convert 1 gram per cubic centimeters to kilograms to cubic meter. And in this case, what information we need to know? As we need to know 1 kilogram equals to 1,000 grams. This is one thing we need to know. The other thing we need to know is the 1 meter equals to 100 centimeters. And this is the conversion factors we need to apply in this case. And let's start here. First, we need to convert grams into kilograms. Yes, this is the first thing we will remember. If we had the denominator, yes, we had, in this case, we had the division of two units, and we will take care first of the units on top. And we need to convert gram into kilogram. Yes, this is the first thing we will do. And in this case, we will use this quality. Yes, we will write how. Now we need to see how we need to write the conversion factor. Then we will write 1 kilogram on top and 1,000 grams in the denominator. It's the only way this gram cancel out with this, and we had the answer in kilograms. Yes, this is. Then we're done with this part. Now we need to take care of the units in the denominator. We need to take care of the cubic centimeters. Then the first thing we need to see is how we need to write the conversion factor. Yes. Then because we had centimeters cubed in the denominator, then we need to write centimeters on top. And this is why we write here 100 centimeters over 1 meter. But now we need to be careful because we had volume units. Yes, we don't have length units, we had volume. Then because we had cubic centimeters here, we need to cube this fraction. Yes, the conversion factor. Yes, we need to cube this one. This is why we had that. And let's move to the next. And we did this part. Yes, I just write again everything. Yeah, and we're done with this part. Now the only way we can cancel out the units, we can cancel out the cubic centimeters if we had cubic centimeters on top. To do that, we need to cube this conversion factor. Then 100 times 100 times 100 will be equals to 1 million. Yes, 1 million. This is why we had here on top cubic. And now, because we need to cube also the unit, we had cubic centimeters. Now, if we cube 1, will be 1. Yes, 1 times 1 times 1 is 1. And we will need to cube also the unit. Now we had cubic centimeters here, and this cancel out with the cubic centimeters. And the answer is in cubic meters. Now we had on top kilograms, and we had cubic meters in the denominator, and this is what we want. Yes, this is what we want. And then we multiply the numbers on top. We had 1 million. We multiply the numbers in the denominator. Yes, it's like fractions. We had 1,000. And if you divide, you will get here 1,000. You just can cancel out this 3, 1, 2, 3, and you will have 1,000. This is why 1 gram per cubic centimeters equal to 1,000 kilograms per cubic meters. And in the test, I will ask for similar problem. Then you had two options. You can complete all the procedure, or just you can say to convert from gram to cubic centimeters to kilograms to cubic meters, I had to multiply by 1,000. I don't like to memorize things. I am not good doing that, but this is something is good to memorize, but you can see it saves a lot of work. Yes, otherwise you had to complete all this procedure. But I want to show you the procedure how to do that. Yes, but you can apply the result. Yes, in most of the cases, if you remember this one, you can apply this result. And let's move to the next slide. Then now the density is a ratio. We know it's the ratio mass to volume. This is we had here. But what happened is, even if in this particular case we had 1, 2, 3, 4 different cubes, yes, 4 different cubes, and the volumes of all these cubes are the same. Yes, it's 1 cubic centimeters. 1 times 1 times 1. And we had 1 times 1 times 1. Then this volume is 1 cubic centimeter. But what happened is the material of each cube is different. In this case, we had gold, we had iron, we had water, we had air. If we can measure the mass, we will find the mass is different, as the mass for each of these cubes is different. As the mass, for example, for the gold will be, let me write here, will be 12. In this particular case, will be 12.3 grams. Yes. Let me write again. The mass for this particular cube will be 19.3 grams. The mass in this case will be 7.9 grams. In this case, the mass of this will be 1.0 grams. And the mass of this one is 0.0 case of the air grams. And we can see even the volume is the same, but the mass is different. Yes, the mass is different. Why if the volume is the same, the mass is different? And the reason is the density of each material is different. And this is why the density of each of these cubes are different. Yes. Then this is why the mass of each of this one is different. Then what happened, we can see, is if the mass is greater, if we had more massive objects, we will have greater density. Yes, for example, here is the same volume, but here we have greater mass, then we will have greater density. Yes, we have greater mass. Greater mass, we will have greater density compared, for example, with water. Yes, then the greater density means more massive material. One more thing I want to tell here is we can see the density identify what kind of material you have. Yes, if the density is 9.3, we know that material is gold. If the density is 7.9, then that material corresponds to iron. And this is why the density is an intrinsic property of the material. It's independent of the quantity. Yes, the density of 1 cubic centimeter of gold and the density of 5 cubic centimeters of gold will be the same. Yes, it's independent of the quantity. And is characteristic of each material. Yes, we can identify the material by the density. And this is why the density is an intrinsic property of the material. And here in this is the table 1.3 from your textbook. And here is the density for some materials. This is aluminum. Yes, we have water here is 1. Yes, for seawater is a little slightly greater than the pure water. But one thing I want to tell here is if we need to convert this density. Yes, you see the unit is gram per cubic centimeters. If we want to convert to kilograms per cubic meters, what we need to do, we need just multiply by 1,000. Yes, this is we did before. Yes, we did all the conversion factor. And if you need to convert gram per cubic centimeters to kilograms per cubic meters, then what you need to do is just multiply by 1,000 or 10 to the power 3 is the same thing. Then let's now try to solve this problem just to take care of the units and the significant digits also when we are solving the problem. And in this case, we had a rock with a volume. Then volume is 4.5 0.50 cubic centimeters, and you can see here volume is cubic centimeters because these are the units of volume. Then mass has a mass of 15.0 grams. Mass, and this is why we had grams, because these are the units for mass. Yes, it's grams. Then now, what is the density of the rock? Then density, right here, density, mass over volume. Mass. Then mass, then we need to write the mass. It should be in grams, yes, in this case. Volume 4.5. If we divide 15.0 divided by 4.50, then now we need to be careful. One thing is to check how many significant digits we had. 1, 2, 3 significant digits. We had division, yes? Then we need to take care of the significant digits in this case. Then we have 3 significant digits in both cases. When we must give the answer with 3 significant digits and the units. And we know these are the right units because these are the units of the density. This is, even if we don't have this part, is if we had 3.33 grams per cubic centimeters, we know this corresponds to density by the units. And then this is the answer. And let's now move to the next example. In this case, we had two blocks. We had two blocks on a table. We had block A. Let me right here, block. And here we had block A has a volume, and then we had volume 3.0, and this block has mass equals to 81.0 grams. Now we had a second block, it's called B, block B, has a volume of 15.0 and mass equals to 135 grams. Which block has the greater density? Then, to compare the blocks, we need to calculate the density. If the two blocks have the same density, what material are they? Then we need to check. The first we need to do is we need to calculate the density. One thing we need to check, if we had the consistent units, we had the same units for volume in both cases. We had grams and we have grams here, no problem, as we can compare the results. Then the units are consistent. Then let's calculate the density for block A, mass over volume. Mass is 81.0 grams divided by 30.0 cubic centimeters. Then the density for block A, let me write here A. Then if we divide 81.0 grams divided by 30.0 cubic centimeters, and we had 3 significant digits, as this division, we had to check the significant digits. Then we need 3 significant digits in the answer, 2.70 and the units. Important to write the units, yes, to know this is the property, is the density. Then here we had the calculation for the first. Let's now calculate the density for the block B. Density equals to mass over volume. then the density for block B will be mass will be 135 grams. The volume will be 50.0 cubic. If we divide these two quantities, then we will get 2.70. Let me write the same way here, 2.70. And now we know both blocks are made the same with the same material. Yes, with the same material. Then now we need to what is the material of this block? Yes. To do that, we need to check some tables. Sorry, here is not good, but here is for example, aluminum is 2.70. And now we know, you see there is another materials we can see here, but this aluminum, yes, is 2.70, then we know the material is aluminum. And both blocks must be aluminum, yes. Then we can identify what kind of material were made these blocks just with the density value, yes, with their density value. Let's solve one more problem. In this case, we had the most dense element, which is osmium, and has a density of 22.6 grams per cubic centimeters. And let's write this information. Then we know the density of this material is 22.6. And now we need to find what is the mass of 6.00 cubic centimeters of this element. Then now we need to be careful when we write here the information we had from the problem, because it's 6.00 cubic centimeters. Even if the problem doesn't say this is the volume, we know 6.00 cubic centimeters correspond to the volume, because these are the units we had here. Yes, by the units we know. And what we need to find is the mass. Then here we know the volume. In this case is 6.00 cubic centimeters, and we don't know the mass. Yes, this is. Now the next thing we want to check is the units. Are the units consistent? Let's see. Then we had grams per cubic centimeters. The volume is in cubic centimeters. Then yes, the units are consistent. As we don't need to, we had the same kind of units in both quantities, then we don't need to do anything with the units. That part is fine. Then now we need to calculate the mass. And we had density, that's why here, density equals to mass over volume. And we need to solve for mass. Then you can think two different ways to solve how to solve this equation. And one is in the way probably you already know. To solve for mass, this equation, we need to multiply by the volume on both sides. Yes. And we had. And now we know. This is one way, and the other way is, let me go here. And we can just use cross product. Yes. Density, we multiply density times volume equal to mass. And mass. And we know volume times density or density times volumes is the same. It's the same thing. Yes, we had the same thing. Let me write here. And either way, you can solve the equation. And now just we replace the values, we plug in the values and find the mass. Yes, then it's volume is 6.00 times density 22.6. Because we need to find the mass, we expected the answer in grams, yes, because this is the units for mass. And you can see this cubic centimeters cancel out with this cubic centimeters, and then the answer is in grams, which is the unit we expected. If we multiply these two values, we will have this answer, 136.6 grams. But we need to be careful because we had three significant digits. Yes, we are multiplying, we had three significant digits. Then let's write this one with three significant digits, and this is the final answer. Yes. And the mass is 136 grams. What I suggest you is first try to solve the equation, and then plugging in the values is easier. I think it's easier. You don't have to deal with the units, here. Then just you had to check the units once you plug in the values. And this one I want to show what is the price for osmium material right now. This is the most dense material in our planet. It's 22.6, and the price from one cubic centimeters cube is 3,188. Yes, this is the price for one of these small cubes. And the reason is very rare, it's hard to get this material. This is why it's even more expensive than gold. In this last example, we had a 2.10 kilograms pile of aluminum cans, which is melted into a solid cube. Then we want to know what is the volume of the cube. Then let's see what information we had. We had the mass. Clearly, the mass of the aluminum cans is 2.10 kilograms. Then the other thing we know is we need to calculate the volume of the cube. If we want to calculate the volume, we know the density equals to mass over volume. Then we know the mass, yes. We don't know the volume, but here we don't know the density, yes, because in this case we had two. If we had two variables that we don't know, then we cannot solve the equation. But we need to read again the problem carefully, and if we read carefully, we know we had aluminum cans, yes, aluminum cans. This is giving the information about the material, yes, the material of the cans. And if we know the material, we know the density, because we know the density identify what kind of material is we had. Then if it's aluminum, then what we need to do is we need to check what is the density of the aluminum. And this, if we check this table, which is in your book, we see the density of the aluminum is 2.70 grams per cubic centimeters. Then let's write this here. This is now one more thing. The next thing we had to check if the units are consistent. And in this case, we had kilograms, we had grams per cubic centimeter. And we can see the units of the mass are not consistent. We had kilograms here, we had grams here. And we need to do something to get consistent units. And there is two possibilities. You can convert the kilograms into grams, or you can change the grams per cubic centimeters into kilograms per cubic meters. As I will write here, there is one option is to convert, and the other option is to convert then we know for the first one we know 1 kilogram equals 4,000 grams. For the second one, we already discussed that, how we can convert gram cubic centimeters into kilograms per cubic meters. Yes, we need to multiply by 1,000, as this is. Then you can solve the problem in either way, because the problem doesn't say in what units you had to give the answer. Yes, in what units they want the volume. Then you can give the answer, the units in cubic centimeters or in cubic meters. Let's try the first way. Yes, let's try the first way. Let's try to convert kilograms, and let's solve this way. Then here we want to convert kilograms into grams. And what we need to know is 1 kilograms equals to 1,000 grams. As this, you can see one thing it will help you to remember if this is the correct equation, the correct equality, sorry, is kilo and 1,000 must be on different side of the equation. You see, kilo must be here, 1,000 must be on the other side of the equation. This is something that is completely wrong, and I will write here this common mistake. See, this is wrong because you see 1,000 and kilo, they are on the same side of the equation. This is not true. Yes, this is not true. This is one way you can check you had the wrong quality. Then let's now 21.0 kilograms. Now we need to write the conversion factor in the right way, and this, we know this is the right way because it's the only way we can cancel out the kilograms and get the answer in grams. This is we want. Here, sorry, here is not 2 point, here is 2 point, here is 2.10. Here also must be 2.10. If we multiply 2.10 multiplied by 1,000, this will be 2,000 grams. And we know this one, 2,000 grams. Now we have the information, we had the information in the same units. We had grams here, we had grams. Then now no problem with the units. The next thing is just to solve the equation. Yes. And we know that density equals to mass over volume. Then in this case the variable is in the denominator. The variable we don't know is in the denominator, which is the volume. What I suggest you is to solve this one using the cross product, will be easier. And you just y over 1, then we multiply, and will be, and then we need to solve for the volume, just we divide by the density. I will write here the other way. You can solve the same, mass over volume. Then The other way you can solve for volume, first you multiply by the volume on both sides, because volume is in the denominator. You need to bring the volume to top, and then you can solve for the volume. Then and you have, now we need to solve for volume. We divide by the density. And either way you can solve in the way is easy for you. I think it's easier if you use the cross product. Okay? It's easier if you use the cross product. Now we can just solve for the volume. Its mass will be 2,100 grams. Divide by the density, but the density is 2.70. And now we divide these numbers, and we will have the volume is 777.7. Now we need to be careful. We need to careful with the units. I will write here units. We know the units we expected is cubic centimeters because it's a volume. Yes, it's a volume. And this, what happened is this cancel out and the units is in volume. But why the units is on top? And let's check this one here. We had grams. Let's write just the units here to analyze why is then we had grams on top, then we had grams. Then remember we say this, we can solve the units in the, we can apply the math to the units in the same way we apply the math for numbers. Then in this case we had the division as two fractions. Then to divide, we change the division by multiplication, and then we flip the fraction. Yes, then we flip the fraction, as you see, we change. Now you can see clearly this cancel out with this one, and the answer is in which is the unit we expected. And see here, check the units. Yes, check the units. And this is why here is cubic centimeters. But now we need to check how many significant digits we had. In this case, we had 1, 2, 3 significant digits. Yes, we had 1, 2, 3 significant digits. We had 1, 2, 3 significant digits in this case. Then we want to give the answer 3 significant digits. 7. Let's write here. 7, 7, 8. Yes, we need to round up. Cubic centimeters. And this is the final answer. Then this is all I had to discuss about the density.